In this lecture, we will discuss the how to solve the linear programming problem by simplex method with one example problem. Let's see the problem. Maximize z equal to 3x1 plus 5x2 plus 4x3 subject to constraints 2x1 plus 3x2 less than or equal to 8, 2x2 plus 5x3 less than or equal to 10, 3x1 plus 2x2 plus 4x3 less than or equal to 15, x1, x2, x3 all are greater than or equal to the 0. Let's see the solution. First observe the given problem is maximization or minimization model. Here given model is maximization, then no need to change the objective function. First step is convert the inequality of the constraint into an equation by introducing slack variables s1, s2, s3. Here three constraints are given and all are having the less than or equal to inequality symbol. So we have to introduce slack variables and replace the less than or equal to symbol into equal symbol. Here three constraints are given. So we have to introduce the three slack variables s1, s2, s3. s1 in the first constraint, s2 in the second constraint, s3 in the third constraint. Then the constraint equations are 2x1 plus 3x2 plus s1 equal to 8, 2x2 plus 5x3 plus s2 equal to 10, 3x1 plus 2x2 plus 4x3 plus s3 equal to 15, and x1, x2, x3, s1, s2, s3 all are greater than or equal to 0. Moreover, modify the objective function in the terms of all the variables, that is maximize z equal to 3x1 plus 5x2 plus 4x3 plus 0s1 plus 0s2 plus 0s3. Second step is find the initial basic feasible solution. For this, we are assuming the decision variables, that is x1, x2, x3 all are equal to 0. Then substitute these values into constraint equations. Then we will get the initial basic feasible solution is s1 equal to 8, s2 equal to 10 and s3 equal to 15. Third step is write the standard form of LPP into matrix form, that is Ax equal to B. Here A is the m by n matrix of coefficients of variables and X is the columnar matrix of all basic variables, that is x1, x2, x3, s1, s2, s3, and B is the columnar matrix of right hand side values in the constraint equation, that is 8, 10, 15. Then write the matrix form. First write the all the basic variables x1, x2 and x3, s1, s2 and s3. Then observe the coefficients of the x1, x2, x3, s1, s2, s3 from the constraint equation. Then matrix A becomes the 2, 3, 0, 1, 0, 0, 0, 2, 5, 0, 1, 0, 3, 2, 4, 0, 0, 1. Then X becomes the x1, x2, x3, s1, s2, s3 and B becomes the 8, 10, 15. Next step is construct the initial simplex table. This is the initial simplex table. Here Cj is the cost coefficients of basic variables which is obtained by observing the objective function. Then the Cj will become the x1 coefficient 3, x2 coefficient 5, x3 coefficient 4, s1 coefficient 0, s2 coefficient 0, s3 coefficient is 0. Then B is the basic slack variables, that is s1, s2, s3, and xb is the basic feasible solution of slack variables, that is 8, 10, 15. and CB is the initial cost coefficient of slack variables, that is 0, 0, 0. Next, we have to fill the remaining values by observing the matrix A. This is the initial simplex table. Next step is calculate the values of Zj minus Cj and check the basic feasible solution for optimality. So first to calculate the Zj minus Cj. Zj minus Cj equal to the CBxj minus Cj. So first to determine the Zj minus Cj value for the first variable x1, that is Z1 minus C1 equal to the CB x1 minus C1. It will become the 0 into 2 plus 0 into 0 plus 0 into 3 minus 3. The value will become the minus 3. Next variable is the x2 variable, that is the Z2 minus C2. It is the CB x2 minus C2. So this is 0 into 3 plus 0 into 2 plus 0 into 2 minus 5. Value will become the minus 5. Next for the x3 variable, that is the Z3 minus C3. It is the 0 into 0 plus 0 into 5 plus 0 into 4 minus 4. Answer is the minus 4. Next for the S1 variable, that is the Z4 minus C4. This value will become the 0 into 1 plus 0 into 0 plus 0 into 0 minus 0. Answer is 0. And next for the S2 variable, that is the Z5 minus C5. It is the 0 into 0 plus 0 into 1 plus 0 into 0 minus 0. Answer is the 0. And next for the S3 variable, that is the Z5 minus C5. So it is the 0 into 0 plus 0 into 0 plus 0 into 1 minus 0. Answer is the 0. Here Zj minus Cj values are the minus 3, minus 5, minus 4, 0, 0, 0. And check the condition in step 5. In step 5, third condition is if more than one Zj minus Cj is the negative, then choose the most negative of them, and this column is calling as the key column. Here Zj minus Cj values are having the more than one negative, that is the minus 3, minus 5 and minus 4. Then we have to choose the most negative value. Here the most negative value is the minus 5 for the column x2. So x2 column is the key column and also calling as the incoming vector. Next we determine the minimum ratio of xb by incoming variable. That is also we can be written as the minimum ratio xb by key column variables. So first we have to determine the xb by this key column variable for the S1. So for the S1, minimum ratio of the xb, that is 8, divided by key column variable, that is the 3. So here minimum ratio will become the 8 by 3. Similarly for the S2, xb is the 10, key column variable is the 2. So that is the 10 by 2. Similarly for the S3, xb is the 15, key column variable is the 2. So it is the 15 by 2. So among these values, we have to choose the minimum ratio. So minimum ratio is the 8 by 3 for the S1. So minimum ratio 8 by 3 and indicate by arrow, and S1 is outgoing vector. Then identify the common element in the key row and key column. Here key row is the S1 and key column is the X2. So common element in the S1 row and X2 column is the 3. So 3 is the common element. Next step is construct the new simplex table by entering the incoming vector. This is the old simplex table. Now modify this table. First enter the incoming variable x2 in the place of the outgoing variable s1. and CB value for the x2 is the 3. Next to modify the row 1, that is outgoing vector divided by the key element. Here 3 is the key element. Then the row 1 will become the 8 by 3, 2 by 3 and 3 by 3 will become the 1, 0 by 3 is the 0, next 1 by 3, 0 by 3 is 0, 0 by 3 is the 0. Next to modify the S1, S2, S3, identical matrix values have to modify. So previously S1, S2 and S3 are the identical matrix. So their values are the 1, 0, 0, 0, 1, 0, 0, 0, 1. Now X2, S2, S3 are the identical matrix. So their values will become the 1, 0, 0, 0, 1, 0, 0, 0, 1. So here I have to modify. So now X2, X2 1, X2, S2 0, X2, S3 0. Similarly, S2, S2 here 1 will become S2 and X2 here it will become the 0. S2 and S3 here it will become the 0. Similarly, S3, S3 1 it will come here. Next S3, S2 0, S3 and X2 it will become the 0. So now I have to modify these values. So these values will become the 0, 1, 0, 0, 0, 1. Next we have to modify the remaining values by following this rule, that is the old element into key element minus multiplication of opposite diagonal elements divided by the key element. First we have to see for S2 row XB value. So old element is here 10 and the key element is the 3 and its diagonal elements are the 8 and 2. So now rule is the old element into key element minus multiplication of the diagonal element divided by key element. So old element into key element 10 into 3 minus of opposite diagonal elements, that is the multiplication of opposite diagonal element, that is the 8 into 3 divided by key element is the 3. Then its value will come the 4.667. So here you have to enter the 4.667. Similarly, next one is for the S2 row and X1. Here old element is the 0 and the key element is the 3. Opposite diagonal elements is the 2, 2. Then value it will become the 1.333. So next one is the S2 row and X3 value. Old element is the 5, diagonal element is the 3 and opposite diagonal elements are the 2, 0. Then it will come the value is the 5. Next one is the S2 row and the S1. So old element is the 0. So and its key element is the 3 and diagonal element is the 1, 2. So now value it will come the minus 2 by 3. Similarly, you have to modify for the S3 row also. For the S3 row and XB value is the 15. So key element is the 3. Opposite diagonal elements are the 8 and 2. So here we will get the value is the 29 by 3. We have to enter the 29 by 3 value. Similarly, next one is the S3 and X1. So old element is the 3, then key element is the 3, then opposite diagonal elements are the 2, 2. Then value it will become here 5 by 3. Similarly for the S3 and X3. So old element is the 4, diagonal element is the 3. So key element is the 3, diagonal elements are the 0, 2. We will get the value is the 4. Similarly for the S3 and S1. So old element is the 0, diagonal element is the 3. Sorry, key element is the 3 and diagonal elements are the 1, 2. So here also we will get the value is the minus 2 by 3. This is the first iteration simplex table and determine the Zj minus Cj values. Zj minus Cj for the x1 is the 5 into 2 by 3 plus 0 into minus 1.33 plus 0 into 5 by 3 minus 3, which is equal to the 1 by 3. Similarly for the x2 variable it is the 0 and x3 variable it is the minus 4 and the s1 variable it is the 5 by 3 and the s2 variable it is the 0 and the s3 variable it is 0. Here Zj minus Cj values are the 1 by 3, 0, minus 4, 5 by 3, 0, 0. Then observe the second condition in the step 5, that is if at least one Zj minus Cj is the negative, then indicate by arrow and this column is called as a key column. Here Zj minus Cj value is minus 4 for the x3 column. So respected column we are calling as the key column, that is the x3 column is the key column and it is the incoming vector. Next we have to calculate the minimum ratio, that is the xp divided by key column variables. For x2 minimum ratio is the xp is the 8 by 3 and key column variable is the 0. Here observe that we calculate the minimum ratio if the key column variable is the greater than the 0. But here for the x1 key column variable is the 0. So here we are not determining the minimum ratio for the x2. Next we have to calculate the minimum ratio for the s2, that is the xb is the 4.667 divided by the key column variable, that is the 5. So 4.667 divided by 5, it is the 0.9334. Next for the s3, that is the xb value is the 29 by 3, that is 9.667 and the key column variable is the 4. So 9.667 divided by 4, which is equal to the 2.41. So here observe the minimum ratio is the 0.9334 for the row S2 row. So here minimum ratio is 0.9334 and indicate by arrow, and S2 is the outgoing vector. Next we have to construct the new simplex table by entering the incoming vector. Next we construct the new simplex table for the second iteration. Here we are replacing the S2 variable with the X3 variable because S2 as the outgoing vector and X3 is the incoming vector. And CV value for the X3 variable is 4. Next we are modifying the row 2 because S2 as the outgoing vector and corresponding row for the S2 is the second row. Then row 2 becomes the row 2 divided by key element. Here 5 is the key element. Then row 2 becomes the outgoing vector variable divided by the key element, that is 14 by 3 divided by 5. It will become the 14 by 15. Similarly, minus 4 by 3 divided by 5, minus 4 by 15, 0 by 5, it will become the 0, 5 by 5, it will become the 1, and minus 2 by 3, it will become minus 2 by 15. So 1 will become the 1 by 5, 0 becomes the 0 by 5, it is the 0. So previously x2, s2 and s3 are identical matrix and its values are the 1 0 0 0 1 0 0 0 1. Now we are replacing the x2 with the x3. So now the x2, x3 and the s3 are the identical matrix. Their values will become the 1 0 0 0 1 0 0 0 1. We have to replace these values for the x2, x3 and s3 make as an identical matrix. Then the remaining values we are modifying by using the this formula, old element into key element minus multiplication of opposite diagonal elements divided by key element. First we have to look for the x2 variable. So for the xb here, that is having the old element 8 by 3. So 8 by 3 and the key element is the 5 and diagonal elements is the 0 and 14 by 3. Here it will come the 8 by 3. Similarly, next one is it will become the 2 by 3. Next it will become the 1 by 3. Next one is the 0. Similarly, you have to replace the old element for the S3 row. So here old element is the 29 by 3 and key element is the 5 and diagonal elements are the 14 by 3 and 4. Then its values will become the here plus 5.933 and next here 2.733 and minus 0.133 and minus 4 by 5. Next to calculate the Zj minus Cj values for the second iteration simplex table, and these values becomes the minus 0.733, 0, 0, 1.133, 0.8, 0. Among these values, 0.733 is the negative value for the x1 column. So here x1 column is the incoming vector. Next we have to determine the minimum ratio. So for the x2 it is the 8 by 3 divided by the 2 by 3, it will become the 4, and for the x3 incoming variable is negative. So here we are not calculating for the x3, and for s3 it is the 5.933 divided by 2.733, it is the 2.17. Among these values, minimum ratio is the 2.17 for the S3. So here S3 as the outgoing vector. Next we have to construct the new simplex table by entering the incoming vector. Next to modify the second iteration table for the next iteration, replacing with S3 with x1 and CB value is the 3. Next to modify the row 3 as outgoing vector divided by the key element. Here key element is the 2.733. Now row 3 becomes 2.17, 1, 0, 0, minus 0.048, minus 0.8, 0.365. Previously x2, x3, s3 are identical matrix and their values are the 1, 0, 0, 0, 1, 0, 0, 0, 1. Now x2, x3, x1 are the identical matrix. So their values are 1, 0, 0, 0, 1, 0, 0, 0, 1. Then remaining values are modifying by the old element into key element minus multiplication of opposite diagonal elements divided by key element. Then their values will become the 1.21, 0.36, 0.195, minus 0.243, 1.51, minus 0.146, 0.121, 0.097. Next step is we have to calculate the Zj minus Cj values. So here Zj minus Cj values are the 0, 0, 0, 1.09, 0.585 and 0. Here observe that one the all Zj minus Cj values are the positive. So if all the Zj minus Cj values are the positive, the optimum solution will obtained. Therefore, the optimum solution is reached with the x1 value is the 2.17, x2 value is the 1.21, x3 value is the 1.51. Then we have to substitute these values in the objective function, that is maximize z equal to 3x1 plus 5x2 plus 4x3. Here I have to substitute x1 and x2, x3 values with the 2.17, 1.21, 1.51. We will get the optimum value for the Z is 18.6. This is the solution, and thank you.